All right, guys, we are on to compositing. Finally. Well, the hardest thing about compositing is color management. And if you haven't seen that course, then you need to watch that, because to explain color management, everything you need to know about ACEs, it's just not reasonable to do that within 10 minutes. That's why I made a whole course on this exact topic. So, assuming that you guys know the basics of color management, I am going to assume that, I'm going to show you how to put together a quick comp with the render that we just made. So, first of all, let's go grab our two things. So, we're going to use our pyro frames, which is right here, along with our backplates. So, let me try that again. Do another file cop. And right now I have our plates right here. And let's say that you're given a plate and somebody just took a JPEG screenshot of where this is going to go. This is a situation where in production, you'll eventually be handed an EXR file, but sometimes you're given something that's just a scratch render or a JPEG or something that's not ideal that you have to work with. This happens all the time. This is not what we see if we just open up that JPEG image. This is what we want to see in our viewer. So let's think through what's happening here. So for one, we read in this file. If we go down to our image color space, that is set to auto detect from the file. And because this is a JPEG, it's a 8-bit image, it's trying to apply some kind of gamma curve to fix that. And the first thing you want to do whenever you're loading anything in is make sure that this is linear. So as soon as we say linear, we have this. And that's obviously not matching what this is doing, but now we can see that this basically has a 2.2 gamma applied on top of what this should be. And actually, if I go here to our little color management tab and I say raw, that's going to perfectly match what we have here in the plates, or roughly match it, I should say. And so what's happening is we're bringing in an image which already has color correction on it. And then we're applying more color correction to try to compensate for our monitor down here. So that's why we have two sRGB curves being applied and everything is washed out. So let's go ahead and create a VOP COP2 filter. If we highlight that, press enter, we can then take our RGB channels and turn that into color. So let's start there. Let's create a float to vector and grab R, G, and B. From here, we have a OCIO transform that allows us to take our color space and transform it into something else. So eventually, that's going to become a vector to float, the new RGB. So R, G, B. So here's how I'm thinking about this in my head, okay? We are applying this ACES sRGB, that 2.2 gamma curve correction, right? And so what I want to do is I want to remove any curves that belong to the raw image right here. So that when I go to apply the sRGB, that is the only sRGB curve that's happening. So I'm trying to strip away the sRGB curve that we have when we view this at the raw color space. So that's what I'm thinking about in my head, okay? So our from space is going to be out sRGB. So that is going to be right here. And our to space is going to be seen linear. By doing that, I've stripped away that 2.2 gamma curve. And now when I reapply it on the display correction, we have what we need to accurately show this off. It's not going to match exactly because we are working with a 8-bit file. And so we are losing detail because it doesn't store the data necessary to do that transformation properly. However, for it being a scratch plate. For it being something that we just need to generally work for right now, this will do just fine until we have the full EXR files. And so that's how we go about the OCIO transform on our plates. Again, that's the most complicated part of this whole thing. So for more information on that, do check out, again, color management. Now, what's happening over here? It looks like everything's working just fine with our sRGB transformation on the explosion, because when we rendered this out, we were saving out raw data. And just like before, if we go down here to our image color space, right now it says auto detect. Because it's a 32-bit image, that will take it as linear, not applying any kind of color transformations, which is good. And then, once again, we apply the display transform sRGB, and that is what we expect this to be. Hopefully that all makes a bit of sense. Again, this is going to be confusing if you've never dealt with color management, so it's something that you guys need to study at some point if that was over your head. Okay. To bring these guys together, we just need to use an over operation. What that will do is it takes our image right here, all the RGB pixels, and it looks at our alpha, which we can see right here, and it uses that as a mask to overlay on top of the beauty pass that we see right here. So that's all we really have to do to get that in there. Obviously, this doesn't look like it belongs in that scene though, so this is where we need to start color correcting and making things feel like they blend in. I'm going to assume that we don't have the luxury of taking the redshift render without any post effects and just figuring out the difference between those two images. That is one way you can go about this. You can actually create a LUT which captures the difference between the redshift with no post effects versus the redshift with post effects. So that is probably the most accurate way of doing it. And I could show you that if you guys would like as well. But what I would say, if you don't have the ability to go ahead and make that custom LUT, is we can just eyeball what this is going to do in order to blend everything in. So whenever you're trying to do color corrections, we need to first of all unpre-multiply everything. And if we go here and we say divide by alpha, we now have essentially gotten rid of any areas that contain transparency. And so the reason why we do this is because when we make color corrections, we don't want any partial 50% effect happening along the edges of our cutouts. If we don't divide by alpha, then it's very easy to get halos surrounding anything that you color correct. So that is why you always divide by alpha. Now the idea is that we'll do that, we'll make all of our color corrections, so we'll just set that right there. As an example, we can, just turn this green or something fun. And once we're done, we'll then pre-multiply again to bring it back to the original states where we multiply by the alpha, and we have these edges preserved. If we didn't do any of this pre-multiplication and divide by alpha stuff, we would have halos surrounding this whole thing. And you can't really see it right now, but it does make a difference, especially when you start making changes to the overall luminance of things. So let's say that I, do something like crazy like that. It's subtle, but we do see that it creates artifacts in the process. So that's why this is best practice to always unpre-multiply before you do any color correction. And well, if you don't know that, now you do. So what do we want to do with the color correct? The first thing that's catching my eye is the fact that this explosion is way more saturated than what we have in our environment. So I'm going to create an HSV node that stands for hue, saturation, and value, and take down the saturation. I find that if we go -0.05, that seems to be a pretty good amount for what this does. And look at this, before, after. It just makes it feel like it now is part of the scene because of the saturation. So that's awesome. So now that I have that going on there, the next thing that we want to take a look at is the shadows. If I go forward here, there's a big mismatch in the luminance of the shadows of our explosion and the plates. So I'm going to use a levels to change that. All we do here is take the output level, start bringing this up ever so slightly until we start essentially changing the blackest black to be hovering around here. So that's already a lot better. But now I want to also match the shadow color. So what I'll do is create a color correct, and I'm going to multiply the shadows by a color that I sample from our plate. So let's go maybe right over here. We have this pinkish color going on, right? Obviously that's too much. So let's bring our value up to 1, and then we take down our saturation to 0, and we bring this up ever so slightly until it blends in a little bit, probably right around there. Maybe a tad bit more, right about there. And so now we have our colors starting to match up as well. Going back up here to the levels, let's take this up a tad bit more, probably right around, that's too far, probably right around there, something like that. And if we take the combination of those two things, we went from that to this. I think our color correct is going a little bit too hot now, so take down our saturation right about there. So before, after. And that also makes a massive difference in trying to make this feel like it belongs to the scene. In the next video, let's add some glow.